When the James Webb Space Telescope was sent off, the expectation was high for it to uncover the secrets surrounding the huge explosion and reveal already unidentified celestial bodies. However, the scientific community was shocked by its latest, remarkable revelation. Renowned astrophysicist Michio Kaku went as far as to claim that this discovery not only deserves a Nobel Prize but also presents a possible threat to the very existence of the universe itself. The question arises, what exactly is this stunning revelation, and are new laws of physics required to explain these perplexing phenomena? Join us as we explore the latest discovery from the James Webb Telescope that could potentially change our understanding of the universe. The James Webb Telescope isn't just humankind's most complex instrument for space exploration, but also one of NASA's most expensive science projects to date. With an extensive construction time of over 20 years and an astounding budget of $1 billion, this telescope has captured the attention and respect of the scientific community. Recently, it has made a remarkable discovery that has left the world in awe. It transmitted the first solid evidence of a black hole. Even more astonishing is that this massive black hole isn't alone, but rather connected to something scientists have compared to the reset button of the universe. Before diving into the implications of this baffling discovery for our solar system, let's explore this groundbreaking revelation. The James Webb Space Telescope, JWST, was designed to succeed the Hubble Space Telescope. Its primary goal is to observe the universe in infrared light, allowing it to see through dust and observe objects that are too faint or distant for other telescopes to detect. The JWST has several scientific objectives, including studying the formation and evolution of galaxies, observing distant objects in the early universe, analyzing the atmospheres of exoplanets, and studying the formation of stars and planetary systems. One of the key features of the James Webb Space Telescope is its large primary mirror, which is 6.5 meters, 21 feet, in diameter and is composed of 18 hexagonal segments. This large mirror allows the telescope to collect more light and achieve higher resolution than previous space telescopes. The mirror is also coated with a thin layer of gold to enhance its ability to reflect infrared light. Another significant instrument on the James Webb Space Telescope is the Near-Infrared Camera, NIRCam, which is designed to capture images of celestial objects in the infrared range. NIRCam is capable of observing objects that are extremely faint and distant, such as the first galaxies that formed in the early universe. The JWST is also equipped with other scientific instruments, including a near-infrared spectrograph, NIR-SPEC, for studying the chemical composition of celestial objects, a mid-infrared instrument, MIRI, for observing the formation of stars in planetary systems, and a fine guidance sensor / near-infrared imager and slitless spectrograph, FGS / NIRIS, for precise pointing and alignment of the telescope. Regarding its launch and deployment, the JWST is a complex mission. It is a joint project of NASA, the European Space Agency, ESA, and the Canadian Space Agency, CSA. The telescope was launched on December 25, 2021, using an Ariane 5 rocket from French Guiana. After its launch, the JWST underwent a series of deployments and maneuvers to reach its final orbit, which is located around 1.5 million kilometers, 930,000 miles, from Earth. Considered the successor to the Hubble Space Telescope, the JWST is generating significant excitement in the academic community. Scientists from all over the world are sharing its images and using the raw data to make new discoveries. According to the Space Telescope Science Institute, since its launch, scientists have made numerous significant discoveries using the telescope. There have been over 750 scientific publications that include a significant amount of data from the James Webb Space Telescope. Let's explore some of the exciting findings made by the James Webb Space Telescope so far. In the 1990s, scientists discovered the first exoplanets orbiting distant stars by observing the slight dimming in a star's brightness when a planet passed in front of it. However, the James Webb Space Telescope has revolutionized exoplanet observation. Equipped with advanced instruments, it can directly capture images of exoplanets by blocking out the star's light. Within a year of its launch, the Webb telescope made history by capturing its first direct image of an exoplanet called HIP 65426b. This gas giant planet is located 100 times farther from its star than Earth is from the Sun. Webb used various filters and cameras to capture images of this massive planet, which were combined to create a composite image. These discoveries not only demonstrated the capabilities of the Webb telescope but also had a profound impact on astronomy. HIP 65426b is unique because of its size, which is 12 times that of Jupiter. Its size and distance from its star made it easier to capture an image. However, the significance of directly imaging exoplanets goes beyond visual appeal. It helps us understand the origins of the universe and the possibility of life beyond our solar system. These images provide insights into planetary formation and exoplanet atmospheres, contributing to the discovery of habitable exoplanets. While habitable exoplanets are currently thought to be rare, the Webb telescope's observation capabilities position it to make groundbreaking discoveries in this area. The images sent by the James Webb Space Telescope have transformed our understanding of the universe. The images showed numerous stars and galaxies, with the older galaxies appearing redder and dimmer. Research from various teams quickly began analyzing these images using advanced computer technologies. Through these state-of-the-art technologies, scientists have been able to extract a wealth of information from each point of light in the images. They determined the age of the light, identified the elements that reflected the light, calculated the speed at which galaxies were moving, and estimated the number of stars within them. However, the latest discovery by the James Webb Telescope has been a source of concern for experts, as it is believed to have the potential to unravel the universe itself. What is this shocking discovery from James Webb, and why is it so dramatic? The James Webb Space Telescope is a remarkable feat of modern technology. Its images have taken us back in time. Through its observations, researchers have made groundbreaking discoveries, including ancient galaxies and a massive black hole with a mass 10 million times greater than our Sun. According to the Big Bang theory, there should have been only stars and star clusters during that time. However, the James Webb Space Earth has been extended by the dark opening's gravity. It is on a direction towards the dark opening and is anticipated to line up with it at last. While the association between the monstrous object X7 and the expected utilization of dark openings as quantum PCs isn't unequivocally referenced, it is suggested that the revelation of X7 started hypothesis about outsider association in quantum processing. Noting that when we discuss outsiders in quantum PCs, we are not envisioning funny outsiders sitting before a black hole surfing the web. Quantum computing is a complex scientific concept that involves harnessing the properties of quantum mechanics for advanced computational tasks. Dark openings have captivated researchers since Albert Einstein predicted their reality in his theory of general relativity. These inestimable monsters, described by extreme gravity, have captured our imagination. They resist the laws of physics in ways that we still don't completely understand. In opposition to past suppositions, the telescope has uncovered that dark openings were more plentiful and massive in the early universe than we initially thought. As of not long ago, specialists believed that dark openings formed when huge stars fell toward the end of their life cycle, resulting in a point in space where gravitational forces become infinite. However, the discoveries made by the James Webb Telescope challenge this understanding. It suggests that galaxies containing dark openings probably existed before the Big Bang, raising questions about the age of our universe or the formation of dark openings. The James Webb Space Telescope has also revealed 6 galaxies that provide evidence of the universe's diversity and complexity. These galaxies represent a beautiful infinite dance, exhibiting the grandeur of the universe. However, amid this magnificence, dark openings arise as terrifying beasts that consume everything around them with their powerful gravity. If dark openings were once dead stars that grew in size by consuming matter or merging with other dark openings, it would have taken millions or even billions of years for them to reach their current magnitude. It is significant to note that the found galaxies existed around 13.6 billion years ago, which implies the Big Bang should have happened 200 million years before the presence of these galaxies. This anomaly challenges our understanding of dark openings, star formation, and galaxy structure. This has not only demonstrated the current theory of the universe's origin to be a simple hypothesis but has also left researchers in anxiety about what this holds for the future of the universe. What does the presence of dark openings mean for our universe? Researchers fear that this could be the beginning of the end. The presence of very massive dark openings at the center of galaxies is a captivating phenomenon that has sweeping implications for the development and evolution of galaxies. These dark openings are incredibly massive, with millions or even billions of times the mass of our Sun. Furthermore, their gravitational pull is so strong that it influences the surrounding stars, gas, and other celestial objects. Very massive dark openings play a critical role in shaping the course of star formation and the evolution of galaxies. When matter like stars and gas approaches the gravitational reach of a very large dark opening, it goes through a process called accretion. Accretion refers to the gravitational attraction that pulls matter into the dark opening. As the matter falls towards the dark opening, it forms a disk, a swirling circle made of hot gas and dust that surrounds the dark opening. This disk is subjected to intense gravitational forces and friction, causing it to heat up to extreme temperatures. The extreme heat leads to the emission of powerful jets and winds of energetic particles from the accretion disk. The jets and winds emitted by the accretion disk can have a significant impact on the surrounding environment. One of their effects is that they heat up the gas present in the galaxy. By warming the gas, the jets and winds prevent it from cooling and collapsing to form new stars. This suppression of star formation has significant implications for the overall structure and evolution of the universe. The regulation of star formation by very massive dark openings is a delicate balance. On one hand, the accretion process provides a source of energy that can inhibit the collapse of gas clouds and prevent the formation of new stars. On the other hand, the jets and winds can also trigger the formation of stars in other regions of the galaxy. The interplay between these processes determines the rate at which new stars are formed and impacts the growth of both the central dark opening and the galaxy itself. The movement of very massive dark openings is also believed to affect the galaxy. The energy produced by the accretion process can drive powerful outflows that expel gas from the galaxy. These outflows can remove gas that would otherwise be available for future star formation. They can also transport heavy elements and other materials produced by the dark opening back into the galaxy, enriching the interstellar medium and influencing the formation of future generations of stars. Researchers have proposed various hypotheses to explain how very massive dark openings form and grow. One prominent hypothesis suggests that massive gas clouds in the early universe directly collapsed under their gravity, forming very massive dark openings. These gas clouds, primarily composed of hydrogen and helium, bypassed star formation and underwent gravitational collapse, resulting in the formation of supermassive dark openings. Another hypothesis proposes that supermassive dark openings grow by accumulating smaller dark openings or stellar mass dark openings. As dark openings consume surrounding matter, their mass increases through a process of mergers and continued accretion. Dark openings can amass enough mass to become truly massive. The merging of galaxies is also thought to play a significant role in the growth of very massive dark openings. When two galaxies collide, their central dark openings can spiral towards each other and eventually merge, resulting in the formation of a larger dark opening. In densely populated regions of galaxies, runaway stellar collisions can occur, leading to the formation of enormous stellar objects or stellar clusters. These objects or clusters can eventually collapse under their gravity, resulting in supermassive dark openings. Furthermore, some theories suggest that supermassive dark openings originated soon after the Big Bang in the early universe. These theoretical dark openings, known as primordial dark openings, would have formed due to extreme density fluctuations in the early universe. Subsequent accretion of mass would have allowed these primordial dark openings to grow into supermassive dark openings. These theories propose that the extreme conditions during the early universe might have allowed for rapid growth of dark openings, bypassing the need for the extended stellar evolution process. However, it is essential to emphasize that scientific research and observations are ongoing, and our understanding of the universe continues to evolve. Researchers are actively studying the behavior of supermassive dark openings, galaxy mergers, and the overall structure of the universe. A telescope has sent pictures uncovering 6 galaxies that were already massive, bright, and filled with stars. What's more intriguing is that scientists hypothesize these galaxies might have very large black holes, which have been detected through gravitational lensing. Black holes are incredibly captivating and mysterious objects in space. They are regions in space where gravity is incredibly strong. Gravity is the force that pulls objects toward one another. When a star is very massive, it can go through a unique process called a supernova. During a supernova, the star explodes and ejects its outer layers into space. What remains is a dense core that can collapse under its own gravity to form a black hole. A black hole is essentially a region in space where this collapsed core has become incredibly dense and compact. It's so dense that the gravity it generates is extremely powerful. In fact, the gravity is so intense that nothing, not even light, can escape its pull if it gets too close to the black hole. That's why it's called a black hole, because it doesn't emit or reflect any light. Supermassive black holes, as the name suggests, are incredibly large and can have millions or even billions of times the mass of our Sun. They are believed to exist at the centers of most galaxies, including our own Milky Way galaxy. The boundary around a black hole is called the event horizon. Once an object crosses the event horizon, it's trapped inside the black hole and can never escape. For this reason, we cannot directly see or detect black holes since they do not emit any light themselves. However, we can observe their effects on nearby matter. Observing black holes and distant objects can be challenging, and as a result, we might miss discovering many of the oldest galaxies and black holes because they are not visible to us. However, with improved technology like the James Webb Space Telescope, scientists are now turning to gravitational lensing for a solution. Gravitational lensing is an effect that can make even old and large black holes visible, which would help us complete our understanding of the early universe. The discovery shook the world of astronomers and cosmologists as James Webb sent photos of ancient galaxies that shouldn't exist. These distant celestial wonders have raised questions that demand critical answers. But that's not all. The telescope's lens has focused on the heart of galaxies, revealing an ultramassive black hole with an incredible gravitational pull that dominates the center of these giant galaxies. This discovery could forever change our perception of the universe, which is why scientists call it the universe breaker. Using NASA telescopes, astronomers have discovered the most distant black hole ever observed in X-rays. The black hole is in an early stage of development and has a mass similar to its host galaxy, a phenomenon never seen before. This finding may shed light on the formation of some of the first supermassive black holes in the universe. By combining data from NASA's Chandra X-ray Observatory and NASA's James Webb Space Telescope, a team of scientists identified the distinct signature of a growing black hole just 470 million years after the Big Bang. The researchers used the gravitational lensing effect from the James Webb Telescope, which acts as a magnifying glass to enhance the light and X-rays emitted by the galaxy and its supermassive black hole. The black hole was located in a galaxy called UHC-1 within the Abell 2744 galaxy cluster, situated 3.5 billion light-years from Earth. However, the Webb data revealed that the galaxy itself is much more distant, at 13.2 billion light-years away when the universe was only 3% of its current age. Webb managed to capture images of these ancient galaxies as they appeared over 13 billion years ago. Observations with the Chandra telescope over a 2-year period confirmed the presence of extraordinarily superheated X-ray emitting gas in the galaxy, a hallmark of a growing supermassive black hole. This discovery is significant in understanding how supermassive black holes can achieve enormous masses soon after the Big Bang. The researchers are investigating whether these black holes form directly from the collapse of massive gas clouds, resulting in black holes weighing between 10,000 and 100,000 times the mass of the Sun. The team, led by S. Bogdan from the Center for Astronomy at Harvard, found strong evidence suggesting that the newly discovered black hole was born large, with an estimated mass between 10 and 100 million times that of the Sun. This mass range aligns with the total mass of the stars in the galaxy, unlike black holes in nearby galaxies, which typically contain only 0.1% of their host galaxy's stellar mass. The massive size of this young black hole, its X-ray emissions, and the brightness of the galaxy detected by Webb support theoretical predictions made in 2017 by co-author Priyangvada Netrajan of Yale University, suggesting the presence of an outsized black hole formed directly from the collapse of a massive gas cloud. As fascinating as this is, it isn't entirely good news for our beloved universe. Can alien civilizations use black holes as quantum computers? In recent news, scientists announced that the James Webb Telescope has made 2 groundbreaking discoveries this year regarding black holes. The first revealed something enormous, an unknown object being pulled into the black hole at the center of our galaxy. The second discovery is even more astounding: advanced alien civilizations are using black holes as quantum computers. These 2 discoveries were made simultaneously, leading researchers to speculate that they might be connected. Scientists observed a large object moving toward the center of our galaxy's black hole. This object was initially speculated to be an alien spaceship involved in quantum computing. However, it was determined to be a massive dust and gas cloud called X7, which is more than 50 times the size of Earth.